4 of quiz 5.1E. We're going to look at the last question, which is given one trig ratio, tangent is 2 over 3, can we find the remaining trig ratios? And they tell us that our degrees are between 0 and 90, so that means that we're in quadrant 1. Alright, so we know that we're in quadrant 1, and the tangent theta is 2 over 3. Tangent is opposite over adjacent. So the one that's missing is the hypotenuse. And you know that opposite side squared plus adjacent side squared gives you the hypotenuse squared. Okay? So then you have 2 squared plus 3 squared equals whatever the hypotenuse is squared. 2 squared is 4, 3 squared is 9. 4 plus 9 is 13. But this is equal to the hypotenuse squared. So if you want the hypotenuse, it has to be the square root of 13. And how do I know that it's going to be positive? Because we're in quadrant 1. Everything is positive in quadrant 1. Alright, so now we have that the opposite side is 2. Adjacent side is 3, and the hypotenuse is the square root of 13. So here we go. Sine theta, opposite over hypotenuse. 2 over the square root of 13. Can't have square root of 13 in the denominator. So you get 2 square root of 13 over 13. Okay, so that's sine theta. Cosecant theta is going to be the flip of this. So you can flip that one, or we can flip this one. So let's go ahead and flip this one. Cosecant is going to be the square root of 13 over 2. Cosine theta. Cosine theta is adjacent over hypotenuse. Adjacent is 3. Hypotenuse is the square root of 13. So 3 over the square root of 13. We can't have the square root of 13 in the denominator, so we get 3 square root of 13 over 13. And we want to get the secant as well. Secant theta will be the reciprocal of the cosine, so we can flip this one, or we can flip this one. I choose to flip this one because then the square root goes on top and the 3 goes on the bottom. Right? I forgot to circle that one. Alright, cosecant, sine, cosecant, cosine, secant, tangent, tangent we know. Tangent theta is 2 over 3. So that means that the cotangent theta is the reciprocal, or 3 over 2. And all of them are positive because it happens to be in quadrant 1. All the trig functions are positive in trig 1.